Hello everybody and welcome to another C++ tutorial for beginners. Now in this video, I'm going to be discussing how you get console input or how you get input from the user. I'm also going to be discussing something I left out in the previous video that I meant to mention and just forgot, which is constant variables. So with that said, let's get into the video. So the first thing that I want to discuss here is something called constant variables. Now, a constant just means that the value of a variable does not change. So whenever you say something is a constant, for example, like gravity is a constant, the rate of gravity does not change. Just like here in programming, when we define a variable and the value should never change, we make it a constant variable or a constant value. So the way you create a constant variable is quite simply, you put the keyword const, C-O-N-S-T, before your variable declaration. Now, there's a few rules when you use const, which I'll discuss in a second, but let's just do an example. So I say const int, let's actually just do the example I just said, gravity, and then we'll make that equal to negative 9.8, and then technically the unit is meters per second, but we're not going to use that, so we'll add our semicolon here. So this is an example of a constant. This variable here cannot change its value. If I try to change the value of this variable, I will get an error. It will say this is a constant. You cannot modify it. This is what's known as a read-only value. So the point of having a constant is just to make your program more clear, so it's easier to actually read through. So rather than writing, negative 9.8, say 25 times in a physics engine or something, you would just define the constant gravity, and then every single time you wanted to use gravity, you would just refer to gravity. So it's very good practice whenever you have a variable that is a constant that's not going to change and shouldn't change, that you define it as a const, and that just enforces in your program that it cannot change. Now, one thing you cannot do with constants is you cannot not initialize them. That's a double negative, I apologize, but if I said const int gravity like this, let's imagine this line was commented out here, this would be invalid. I cannot define a const unless I give it a value immediately. So if I actually compiled my program here, I'm just going to save us the time of not doing this, you would see that this would be an error. So those are consts. Just wanted to go over those quickly. Whenever you see them, just understand they are read-only values. They are meant to be accessed. They could be used, but you cannot change their value. So now that we've discussed constant variables, we can start talking about getting console input. So we saw previously that there was this command called cout, standing for characters output, that is a part of the IOStream library, so input output stream. Now, as well as cout, there's this thing called cin. Now, it's pretty intuitive. This stands for characters input. But this time, instead of using the, stream insertion operator, after this, we use the stream extraction operator. What this is going to do is extract the characters from the stream that we typed in, the stream being the console, and it's going to take whatever those characters are, and it's going to try to convert them to a certain type and store them in a variable. So in this case, if I say cin, and then I say the two greater than signs, which is the, I'm always mess up this name. What is this called again? The stream extraction operator. Not an easy thing to remember. What's going to happen is it's going to try to store all of the characters that we type before we press the enter key on our keyboard in the variable n. Now I need to define the variable n because right now n is not defined. So when I define the variable that I want to hold whatever was typed in from the console, I need to pick its type. Now the type I pick is the value or the type of input that we are going to be expecting the user to type in. So for example, if I say int n, this means that my console input, or I'm expecting my user to input a value that is a number, to input an integer to be specific. If I don't input an integer, I am going to get an error. So I need to make sure I input an integer, otherwise there's going to be a problem in my program. And I'll show you how we fix that problem in a minute. But anyways, this is the most basic form of getting console input. You define a variable, you define the type of that variable. This is the type that you are expecting the input to be. You then write cin, you write the stream extraction operator, and then the variable that you want to store whatever was in the stream, whatever the input was. So let me show you what happens when I run this. Let me compile my program and let me run my program. Notice that what happens is my program is kind of sitting idle right now. It's not really doing anything, and my cursor is flashing. What that means is I'm waiting for input from the user. So in this case, let me type something like 3. When I type 3, all is good, no error. It goes to the next line. Notice that after your input, so after you press enter, it automatically goes down to the next line, and then my program is done and all is working. So to make sure this actually worked properly though, what I want to do now is cout the value of n to make sure it actually did get the correct value. So let me cout n, after I get the input and store that in the variable n, so we can see what the variable n is equal to after it's assigned the input. So let's do this again. Let's compile, let's run, let's type 3. Notice it prints out 3, all is good. Now let's see what happens when I print something or when I type something in that's not valid input. So actually, let's go with 6.7. When I do 6.7, notice C++ is smart enough to realize that, hey, this is not an integer, but I can convert it into an integer just by slicing off the float. So it goes ahead and does that and gives me the value 6, which is great. It caused us not to have an error in our program, and we still get some, meaningful value, although it's not the exact value that the user typed in. However, what happens when I type something in that cannot be converted to a string? Well, if I type, say, hello in here, notice we get the value 0. Now, this does not mean that hello is equal to 0. In fact, just to prove this to you, if I type in, say, y, this also gives me 0. The reason this gives me 0 is because there was an error in the cin kind of function, program, whatever you want to call it. So it actually just assigned a default value of 0 to this variable because cin just returned the value 0, indicating that there was indeed an error. Now, this is not super clear, and whenever there's an error in cin, what actually happens is it throws what's known as an error flag to the state of our console input stream, or of our character's input stream. What that means is after there's an error in any of our inputs, because we can collect multiple inputs, we don't have to do this just one time, we can no longer collect any more inputs until we clear that error. So this is very kind of hard to explain and strange because you can't really see all of this that's going on. But as soon as we type an invalid input, all of a sudden our character's input function, or whatever you want to call it, now throws an error flag to the console. And this tells the console we need to resolve this error before we can collect any more input. So to show you what I mean by this, let's add another cin. So let me just copy this. And I'm going to go cin. I'll make another variable. Let's just call this x. And now we'll cin some value into x. And we can also cout x after this as well. So we'll cout n and we'll cout x after we take our two inputs. So let's try this now. Let's compile our program. Let's run the program. And let's start with valid input. So let's go with 3 and 4. Notice it prints 3, 4. It didn't print the new line because we didn't tell it to print the new line. So now if I want to print the new line, I'll say end L. Let's recompile. And let's run again, and let's go 3, 4, and then we get 3, 4, right? And it removed that space. It just converted it into an integer. Okay, great. So now that we know that that works, let's try this with invalid input. So let me start by inserting something that's valid, 3. Now let me insert something that's invalid. Let's go with h. And as soon as I do this, I get 3, and then I get 0. The reason I get 0 is because cin returns 0 because there was an error. H is not a valid input. It cannot be stored in the variable x, right? So it just automatically put 0 there. Now let's see what happens when I start with an invalid input. So the first cin is invalid. If I type h, notice immediately it just stops. The program actually just finishes, and there we go. The reason this happens is because our next cin right here cannot run. Notice it only asked me for one input, right? I just typed in h, and then all of a sudden it printed out two values. It didn't ask me to type something else in. That's because there's now an error in cin. And since there's an error, we need to clear that error before we can actually collect any more input from the user. So that's something to keep in mind. As soon as you have an invalid input, you need to clear that invalid input to ensure that you can now collect more input afterwards. Now notice it prints out two kind of random values here. So n is equal to 0. The reason n is equal to 0 is because cin returned 0 because this was invalid input, so that get assigned to the value n. And then x has this random value right here. Now you can't really say anything about this random value. The reason this is random is because at this point in time, x is kind of just randomly holding something. When you define variables in this way and you don't give them a value, by default, they're going to have some value that's just already stored in memory. This is very difficult to explain without going too in depth, but you can kind of imagine that all of our variables are sitting at some location in our computer's memory. And until we tell that location what it should store, it just has some random value inside of it. We're not clearing anything out of our memory locations until they need to be used for something else. So as soon as a variable is no longer being used, then it just has the value it had before. We don't clear it out necessarily, at least in this kind of example right here. This is very difficult for me to explain again without getting too much in depth. But just think of it like this value was being stored where x is, and since we didn't assign anything to x, it's just still storing that value. So we just end up printing this random value. I'm actually almost sure if we do this again, let's just see what happens if we do this again. We go h, notice it prints the exact same thing. So this is just what x is storing right now because we haven't set x to anything else. So again, that's why we get that random value. Not super important to understand that. But now let me show you how we can fix this error, right? Because this is annoying. Obviously, if we type in invalid input here, we want the rest of our program to still work properly. We still want to be able to get input. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is AlgoExpert. AlgoExpert is the best platform to use to prepare for your software engineering coding interviews. They have over 140 coding interview questions on the platform, all of which have a conceptual overview and code walkthrough, which are taught by the best instructors, one of which is me. Check out AlgoExpert from the link in the description and use the code TechWithTim for a discount on the platform. So there's a certain way that we can do this. First of all, I'm going to show you how we can check if we got invalid input. The way that we can check if we got invalid input is we can see out this right here, which is called cin.fail. Now, when you call this, which is known as a method, we'll discuss this later in the series, what this tells you is whether or not there was a failure in your input or not. So if there's a failure, this right here is going to be equal to 1. If there was not a failure, this is going to be equal to 0. So let me just show you. It's best to do this with an example. Let's compile our program. Let's run our program. Let me type something in. Let's type H. Notice we get 0 printing out, and then it's still, oh, what the heck? Did I not compile my program? Oh, I didn't save it. Sorry. This was running the previous version of my program. I need to recompile it. I was wondering why that was happening. Okay, let's try this. So if I type in H, notice it prints out 1. The reason it prints out 1 is because there was a failure. This was invalid, right? Our input. Now let's run this again. If I type in 1, we get 0. That means there was not a failure and all worked fine. So you can check if there's a failure by looking at cin.fail. This will be important when we can actually use this to, say, fix the failure automatically. Now, we can also just fix a failure. The way that we can fix a failure is by writing the following command. When we write cin.clear, what this is going to do is clear the failure from our console input stream. Now, this kind of works, but you're going to see that we still get the same error even when we clear this error. What this does is this removes the error flag from our console input stream. However, it does not remove the text that was typed in the stream. Now, I understand this is totally very vague and confusing, especially if you've never seen something like this before. But again, what's happening is when there's an error, we're throwing an error flag to the console. So there's an error flag on the console. What this clear line does is remove that error flag. However, it does not remove the text that is typed in right now to the console. So we need to now remove the text that is typed into the console from kind of our console stream here. Otherwise, we're going to get the exact same error happen again. So what I do after this, after I clear the error flag, is I say cin, and then I say .ignore. And what this does is ignore a set of characters. In fact, what we type is the following, the number of characters that we want to ignore. So to be safe, you can just make this value super large, and if the number of characters that were typed in was less than this value, it will just ignore however many characters were typed in. But let's make this something like 1,000. What this means is that as soon as I hit this line, cin.ignore, if I had whatever number of characters I had typed in, we're going to clear 1,000 of those characters from the input stream. So the next time I go to get input, I am not considering those previous characters that were typed in, because if I don't do this, we're going to consider those previous characters. So now what I add after this is 1,000, is I add a \n. And what this is going to do, and sorry, this needs to be in double quotation marks, not single quotation marks, is it's going to skip us down to the next line. So you saw previously what happened was as soon as we had a failure, the next console input or the next line that executed happened right after that failure. Now, I'll kind of show you this example again. Let me just get rid of these 2 lines. Let's say cin, and let's go to x, and then we'll just say cout, and we'll see out here the value of n. Okay, so let's run this program. Let's compile this just so I can show you what I'm talking about. So let's run this, and let's type in something invalid, which is h. Notice we just print out 0 immediately. We just skip the cin. However, if I were to print out something else, let's do this. Let's go cout, and then let's go n, and then let's go cout, and let's do x. Let's see what this one looks like. I'm trying to find a good example here. Okay, so invalid, and then what happens is it prints out 0, and then it prints out whatever the next cout is immediately, right? Because this cin, since this didn't run, it didn't move me to the next line. So what happened was we kind of squished these 2 outputs together. Now that's no good. We don't want to do that. So what this \n does here on this line is it moves us down to the next line after there's a failure from our cin. So now let's see what happens when I put these 2 lines right after this cout of n. So now, regardless of whether this was valid or not, I'm going to clear any potential error flag. I'm going to ignore 1,000 characters. I'm going to skip down to the next line, and then hopefully this cin should just work. So let's see, again, you can have a look at this code. I don't want to fast forward through it too fast. And let's go now. So let's say G++ -O, and we seem to have gotten an error. Let's see, what have I messed up here? So it turns out I was actually right the first time when I had the single quotation marks. This needs to be single quotation marks, not double quotation marks. The reason for this is .ignore accepts 2 arguments. Arguments are just things that go inside of the parentheses when you call this, and the things that it accepts is an integer and then a character. So rather than accepting a string, it takes a character, which means I need to put single quotation marks around this. So now let me recompile. That's kind of what the error was telling me there. There was an error with \n. So let's run this. There you go. The compilation is good. Run the program. And now let's do something that's going to error out. So if I type H now, notice it prints 0. But now it still lets me type something in, right? It doesn't immediately stop and go to the end of my program. I can now type something in. So now what I'm going to type in is hello. And then I get 0 again because, well, hello is invalid. But if I run this one more time and I type, say, H, which is invalid, and then I type, let's go like 12, 12 actually works. And now I can now print this out. So some of you may be wondering why this didn't go down to the next line, right? Because I was saying the reason we added the \n is so it moves down to the next line. Now, technically, the reason this happened is because after we did this cout here, we didn't move to the next line. So if I were to add a new line after this cout, then this would actually work properly. Because the way it stands right now, even if I type in 2 valid things without these 2 lines, so let's actually do this. If I go G++ and then run program and I type, let's go 1, and then on the same line again, it's asking me to type another number, right? And then it prints out 2 because I didn't add the new line after my first cout. So technically this is actually working the way it's supposed to work. And just to show you, let's add an end line here. This is what we probably should have done the first time. Let's compile, let's run, let's type in something invalid, and then notice it goes down to the next line, and now we can type something in. So let's go with 3. 3 is valid, it prints it out. So hopefully that makes sense. If the \n is not making sense to you, don't worry about it. Just add it into the end of .ignore. And this number here, you can just make some, arbitrarily large number that ignores the number of characters, right? So you want to make this at least as large as the number of characters you expect the user is going to type in. It will then ignore that number of characters, and then you will have valid input again. So there you go. That is kind of how you get console input. I understand the cin.clear and ignore is kind of confusing, but I just wanted to show you this because oftentimes you want to get multiple pieces of input, and you can only get those other pieces of input if all of the ones before it were valid. So if you want to make sure that you're going to handle any situation where you potentially have invalid input, you can just put this, because even if you have these 2 lines, right? And then we run this and we actually type in 2 valid things. We type in 2 and then we type in 3. This still works, right? Clearing something that doesn't have an error just doesn't do anything. And ignoring characters from the stream that aren't there just doesn't do anything either, right? Because as soon as we get this input, it will automatically kind of ignore the characters for us. The only situation where we need this is where we have an error in the first input. So hopefully that is clear. The last thing I will show you here is how to build like a super simple calculator just so we can apply this into a little script. So let's do this. So I'm going to delete all of this, and what I want to accept is 2 integers. So I'm going to say int num1 and num2. The idea being I want to take 2 numbers and then I want to add them together. So what I'm going to say is cout, and I'm going to cout enter a number like that. So I want the user to type a number. I'm then going to say cin, and I'm going to cin to num1. Now notice I didn't add an end line here because what I want to happen is the user to type at the end of this right here. So after this colon, I have a space, and then I want the user to start typing. So I'm going to copy this line. I'm going to put it right here. So after the cin, assuming I get valid input, what's going to happen is it's going to move me down to the next line, and then I will print enter, and we can say a second number. And then this one will be num2. Then what I'm going to do is I'm going to say cout. I'm going to cout the sum of these numbers. So I'm going to say int sum equals num1 plus num2. And I'm just going to cout the sum like that. And actually, before I cout the sum, I'll say the sum is colon and then a space and then whatever the sum is. So there you go. Let's test this program out. This should ask us to enter a first number, a second number. We should then add them and we should print out the sum. So let's compile and we get an error. What is, oh, num, sorry, this needs to be not num, sum. Okay, just a small typo. I had num there instead of sum. So let's try this again. Looks like we're all good. Run the program, enter a number, go 3, enter a second number, 5. The sum is 8. Awesome, all is working. So now let's see what happens if we have an error. If I type H, notice that it just, crashes and just goes through the rest of the lines because we now cannot get the second console input. So our second number, we don't assign it some value. So it has whatever was just stored in memory at that location beforehand. So if we wanted to fix that, we would need to add the lines I showed you before. We're going to say cin.clear, and then we're going to say cin.ignore, and we're going to ignore 1,000, and then we're going to say \n like that. Okay, so let's add our semicolon. Let's try this now. So compile, run, let's enter an invalid number. Let's just go with he. Okay, it still moves us down to the next line. Type in number 3. Then notice the sum is 3 because the first number here will just be equal to 0. We will add it to 3, and then all will be good. So the last thing I'll show you here is how we can get an input that is a string or is a float, because I realized I didn't show you how to get any other type of input. So let's create a variable here, and let's say string. Let's just call it s, why not? And then we will say cin, and we will cin to s, and then we will cout, and we will cout s. So just a super simple example. So let's go and compile our code. So I'm going to compile it here, and then I want to run my program. I guess I hadn't already typed that in this console. So run program. Notice my cursor is ticking. Now I type hello, and hello prints out. So that's as simple as it is to get string input. Anything you type when you have string as your input type will be valid. So even if I type, and let's just run the program here, say 1, this is still valid. The reason this is valid is because when you write string as your data type here, anything can be converted into a string. So even if I type a number, that can be converted into a string. We just put double quotation marks around it. Boom, there we go. We have a string. Even if I type like a Boolean, right? Like true, this just converts to a string. That just works fine. If I type, say like 1.6, works, it's a string. So it's always safe to use a string as your input type. If you don't care about the actual value, like you don't care about, say, adding two numbers together, then you can just use a string. However, if you want to get the integer representation of a number, you would want to use int, right? You would want this variable to be an int. And just as a little brief example here before we end the video, let me show you what happens when I try to add something to s. So let's actually create a new variable here. Actually, I can't do a new variable because it will give it away. Let's do something like s plus 1. Okay, so let's say I want to add 1 to s. Let's see what happens when I actually try to do that. So when I do that, I'm going to run, I need to recompile my program. So let's recompile. We get an error. The reason we get an error here is because, well, we cannot add an integer to a string. So that's just to show you that if you wanted to, say, add a number or add something to the number that's inputted, you would want that number to be an int, or you would have to convert what is typed in from a string to an int, which we're not going to talk about now. We'll talk about in later videos. So hopefully this didn't confuse you too bad, but the idea is just that the type really does matter. And when I say string, this means whatever's typed in, even if I type an int, it's going to be a string, which means I can't do something like add a number to it because that's just an undefined operation. How do you add 1 to the string Tim, right? That's undefined. There's no way to do that. So hopefully that kind of makes sense, but I just wanted to show you string. Now, of course, if you made this float, this will just work. Like if you type a floating point value, you will get a floating point value. If you type an integer value, this will work as well because any int can be represented as a float. If you type a string, well, you'll get an error because you cannot convert a string to an int. So hopefully that's clear, but with that said, I'm now going to conclude this video. I hope this was helpful to you. If it was, make sure you leave a like, subscribe to the channel. I will see you in another C++ tutorial.